to the Arecibo Observatory, home of the world's largest and most powerful telescope for radar and radio astronomy. The Arecibo Observatory, set amid the limestone hills of northwestern Puerto Rico, is a monument to human curiosity, to a quest of understanding that began before the dawn of history. With this instrument, scientists can examine phenomena that occur as close as 3 kilometers above us in the Earth's atmosphere, or probe the hearts of quasars, 10 billion light-years away at the very edge of the discernible universe. Since its completion in 1963, the Arecibo telescope has been used by thousands of scientists, some of whom have made Nobel Prize-winning discoveries. The Arecibo radar telescope was conceived by William E. Gordon, who hit on the idea of using a spherical bowl-shaped reflector fixed on the ground with a movable receiver hanging above it. This permitted the beam to point in a 20-degree range of direction around the zenith, or overhead direction. Such a telescope is most useful in Puerto Rico, a location where the sun, moon, and planets pass almost directly overhead. With the completion in 1997 of the Gregorian reflector system suspended 137 meters above the telescope dish, the Arecibo telescope remains unmatched in its sensitivity and versatility for radio studies of the atmosphere, the solar system, and the universe. The telescope has a frequency range between 300 megahertz and 10 gigahertz. The Arecibo telescope is huge. The main reflector dish has a diameter of 305 meters and a depth of 51 meters, covering an area almost the equivalent of 26 football fields. The dome containing the Gregorian reflector system is 6 stories high and weighs 68 metric tons. The size of its reflector is what makes the Arecibo Observatory so useful to scientists from the United States and around the world. A larger size means a larger collecting area, which allows weaker radio signals to be detected and a more accurate measure of particularly interesting sources. The main reflector collects the radio waves and reflects them to the Gregorian reflector system, which concentrates the signal and sends it to the receivers. Information then travels along cables to the main research building, where specialized equipment converts it into digital format, uses a computer to analyze it, and finally stores it for future reference. Most of the observing time at the Arecibo Observatory is assigned to receiving, detecting, amplifying, and recording electromagnetic radio signals produced by distant astronomical objects like pulsars, stars, interstellar clouds, galaxies, and quasars. Many of the known pulsars were first discovered at Arecibo, and it is expected that far more will be discovered in the future. The first pulsar in a binary system was discovered by Russell Hulse and Joseph Taylor in 1974. The discovery of this pulsar made possible the confirmation of Einstein's general theory of relativity. Taylor and Hulse were awarded the 1993 Nobel Prize in Physics for that discovery at the Arecibo Observatory. Another famous Arecibo discovery concerns the rapidly rotating pulsar B1257+12, which was found to have 3 planets in orbit around it, the first Earth-like planets ever detected outside the solar system. The Arecibo Observatory celebrates the International Year of Astronomy with the commitment to operate on a continuous basis, 24 hours a day, every day, providing observing time, electronics, computer, travel, and logistics support to scientists from all over the world. The universe, yours to discover.